Hello guys, in this video we are going to discuss the solution of the problem split linked list alternatingly. So let us look at the problem statement. The problem statement says given a singly linked list head, your task is to complete the function alternatingSplitList that splits the given linked list into two similar lists. The sublist should be made from alternating elements from the original list. Note, the sublist should be in the order with respect to the original list. You have to return an array containing both sublinked list. So for instance, if this is the array which is given to us, so from this original linked list, all odd position linked list has to be made into one list and all even position list has to be made to one list. And then we need to return the head of these two linked list. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say this is the linked list which is given to us. The first thing which we are going to do is we are going to preserve the next node and we are going to extract the current node from the original list. So let me explain what do I mean by this. Well, what do I mean is, first what we are going to do is we are going to preserve this node. So let's call this as next. So we are going to preserve this and our head pointer was here, and the next is something which we have preserved in the variable next. And once we have preserved the next node, we are going to extract the current node from the original list. And by extracting, what I simply mean is I'm going to remove this connection, and we will also have a count variable which indicates whether the node is at even or odd position. The initial value of this count variable will be 0, so 0th node is an even node. Next, what we are going to do is we are going to append all even node to a list denoted by LL0, and similarly we are going to append odd nodes to a list denoted by LL1. And what is this LL? Well, LL is simply a list whose default value is none, and these two elements points to the head of the newly created linked list. Now let us discuss how we will be able to insert nodes in LL0 or LL1. So for that, what we are going to do is we are going to take two pointer, last one and last two, and default value of these two pointer is none. Similarly, we are going to take a list and default value of this list is none, which simply means head of both the list is none to begin with. And this last one and last two points to the last node of list 1 and list 2. And then to insert a node into a list, there will be two conditions. First condition is when the list is empty, and let us say we are inserting node into LL0. So in such case, LL0 will be equals to none, and all we have to do is we have to set LL0 is equals to head of the linked list. And at the same time, we will also ensure that last one points to the head of the linked list, which is the last node of the linked list. And the second condition is when the list is not empty. In such case, last one points to the last node of the current linked list. So all we have to do is we have to set last one dot next equals to current node, and then last one has to be moved to the last node. And the way we will do this is last one is equals to last, and in this way we will be able to append nodes in a linked list. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to alternating split list. So for that, what we are going to do is we are going to take a list and the default value is none, and then we are going to take last one and last two pointer and default value is none. Also, we are going to take a count variable, default value is 0, and then we are going to iterate on the linked list. So while head, and the first thing which we are going to do is we are going to extract the current node from the original list. So let us do that. So for that, let's preserve the next pointer, so head dot next, and to extract, all we have to do is we have to set head dot next equals to none, and then this current node has to be inserted in linked list 0 or linked list 1. So let us do that. So if count modulo 2 equals to 0, then that simply means that the current node has to be inserted into LL0. For that, let us check if LL0 is empty or not. If LL0 is not empty, then last one will be set to the last node of LL0, in which case all we have to do is last one dot next is equals to head. Otherwise, the list is empty and we need to set the head of the linked list. So LL0 is equals to head. And then towards the end, all we have to do is we have to update our last one to last node of the LL0. So let us do that. And similarly, if let us say this is an odd position node, so the same thing has to happen for the LL1 list. So let us do that. So if last two, then last two next is equals to head. Otherwise, LL1 equals to head, and then last two equals to head. And then let us update our head pointer. So now head will be equals to next. We need to move to the next element, and let us update our count variable by 1. And towards the end, we just have to return LL. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. Over here we have LL, and then we have last one and last two set to none and count equals to 0. Then we are iterating on the linked list. First thing which we did is we extracted the current node from the original list. Then we are checking whether count modulo 2 equals to 0, which simply means the node has to be inserted in LL0, and then we inserted the node in LL0. Similarly, if count modulo 2 is not equals to 0, then the node has to be inserted in LL1. And towards the end, we updated our head and count variable and return LL. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. We have a vector LL, last one and last two equals to null and count equals to 0. Then we are iterating on the linked list. And the first thing which we did is we extract the current node from the original list. Then depending upon whether it is an even position node or an odd position node, we inserted it into LL0 or LL1. And then we are updating our head and count. And finally, we are returning LL. So that's the C++ implementation, folks. Now let us submit our solution. So the C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.